Hello friends, today I'm going to solve LeetCode problem number 226, invert binary tree. So here in this problem we are given the root of a binary tree and we need to invert the tree and return its root. So first of all, let's see what's a binary tree. So binary tree is a tree which has a root node. It starts with a root node and then it has two children. Since it has two children, hence binary. Now there is a property of binary tree, that is any value less than the current node is goes towards the left node, and any value greater than the current node goes towards the right node. So here let's suppose if this is equals to 3 and if we have a value 1 that we need to insert, then this one will go towards the left node, so it will go here. Now let's suppose we have a value equals to 4 is greater than 3, so it will go to the right. So this is a binary tree. Now we need to invert this binary tree. Invert means just the opposite. We have the root. Now towards the left, all the values greater than 3 will go towards the left, all the values less than 3 will go towards the right. So 4 will be towards the left and 1 will be towards the right. So this is what inversion of binary tree means. Now how can we actually solve this problem? So let's look at this example here. So we are given the root here and now we have the okay, so we have its children. So what's happening? 4, we have the root node and then now we have its children. 2 goes towards the right, so here it's towards the left, here it's going towards the right. What about 7? 7 is here towards the right but it's towards the left here. Similar is for this subtree as well. In case of 2, which is the root node, there we are just shuffling the children, right? So that's what we are going to do. We are going to shuffle these two nodes. So instead of left, it will go towards the right, instead of right it will go towards the left, and so on with its children as well. So that is what we are going to do. And since this problem can be divided into sub problem, as for 4 we need to shift 2 towards the right and 7 towards the left, we have to do the same for the children of 2 as well. So it forms a recursive form of solution, as this problem can be divided into sub problems. So using recursion we can actually solve this problem. So let's see how we can do that. So we are going to use the same function and call it again and again. So what we need to do is, okay, now let's go towards the very end. All right, so in the very end, just a single node here and it doesn't have any children. So if it doesn't have any children, when we are recursively calling it's one of its children which is null, then what should we return? We need to return null, right? Because we can no further proceed. So if the root itself is null, then we cannot proceed any further. We are not going to do any more recursion, so we just return null. If we have the root value, then we take the left value. Okay, so we take the left root left node, that is left subtree, and the right subtree here, and now we need to shuffle the left and right. To the left we need the right subtree, so invert tree, and here we are going to pass the right. Why are we passing the right into a function? Because we now recursively need to shuffle the left and right sub nodes of this subtree as well, right? As in this case, while we are shuffling 2 and 7, this whole subtree and this whole subtree, now we need to shuffle the next its children as well. So that's what we are doing here. And then similarly for right, we are going to do the same thing, because we need left towards the left, we are putting the right, towards the right, we are putting the left, and this will shuffle its children as well. And finally we are going to return our root after shuffling. So that will be our answer. Okay, so one problem here is we are putting root dot right. Till here it's fine, but when we are passing root dot left here in this recursive call, we are actually passing this updated values. We don't want to pass that. We want to pass the left node which we had earlier. So let's do the same here as well. So now let's run our code. Great, let's submit this. Awesome. So here we are able to solve this, and it is solved in O of n time complexity. And talking about the space complexity, since we are performing a recursive call which takes a stack, and the length of the stack can be O of n, so that is why the space complexity also becomes O of n. So in this way we can actually solve this problem. So let me know in the comments down below what do you think about my solution. Thank you.